So we're back in the coordinate plane for this part, which should be no surprise to anyone because we keep going back to the coordinate plane all year long. And first question of the day, what is the midpoint formula? That's your first Edpuzzle question of the day. All right, now that we have that, we're going to go ahead and start working with parallelograms in the coordinate plane. Basically, when we are dealing with something in the coordinate plane, we're always going to have to prove things using our formulas. You're going to have to find lengths of sides. You're going to have to find if sides are perpendicular or not. You're going to have to find midpoints. And we do that using distance formula, midpoint formula, slope formula. Now, if you're in my class for a semester, you know that I said I'm not going to be giving you these formulas anymore. We're going to go over them on the board and stuff like that, but do not ask me in class what those formulas are. We've been working with them all year long. You are responsible for knowing those formulas and having them memorized. If you do not have them memorized, I'm so sorry, but you need to find them and get them memorized to make flashcards, do whatever is necessary. Absolutely, you will need to know those formulas. It says the coordinates of the intersection of the diagonals of element O, find the coordinates of that with these coordinates for the vertices. So L is at 1, 4. Let's go ahead and do that. L is at 1, 4. There's L. M is at 7, 4. N is at 6, 0. And O is at 0, 0. So as I'm drawing my parallelogram, notice that we go around alphabetically in order. I don't cut through the middle when I'm drawing my parallelogram. We just go ahead and draw those 4 points in. And yeah, it is in black, so it's kind of overlaps, but you get the idea. There's my parallelogram. The question here says, find the coordinates of the intersection of the diagonals. Well, the two diagonals should have, by definition of a parallelogram or by theorem, we know the diagonals bisect each other, which means they share the same midpoint. So if I want to find where the diagonals intersect, I find the midpoint of both diagonals. The diagonals are LN and MO. So I need to find the midpoint of LN. And by the way, when you are doing this, that looks kind of like angle N, so I'm going to make that a little more clear. Okay. When we are doing something, when we are doing a calculation, please, please, please write down what calculation you're doing. Don't just throw the numbers up there because I don't know what you're calculating. You're communicating every time you write in mathematics. So write down what it is you're doing. The midpoint of Ln equals, and show your work. Ln, it's x1 plus x2, 1 plus 6 over 2, 4 plus 0 over 2. So that's 7 over 2, 2. 7 halves 2. Next, we need to find the midpoint of MO. And again, we do the same thing. 7 plus 0 over 2, 4 plus 0 over 2, and that's 7 halves, 4 halves, which is 2, sorry. Notice they're exactly the same midpoint. So that is the point of intersection of my two diagonals. And that's one way I can work with parallelograms. I can actually find that they have the same midpoint. The diagonals have the same midpoint. And again, it has to be the diagonals. I'm not concerned at this point with the midpoints of the sides. I'm only concerned with the midpoints of the diagonals, not the midpoints of the sides. Sides, I might be more concerned with the slope of the sides or the lengths of the sides, which would be a slope formula or a distance formula. Okay? So, just working backwards here, I could very easily say, show that the opposite sides are congruent. So if I said, show the opposite sides are congruent, how would we do that? Again, distance formula. Congruence is shown by finding length, which is distance formula. Now, we're fortunate that we have some sides that are perfectly horizontal here. So I don't really need to use distance formula here. I can just count off boxes, and I can say, okay, LM clearly equals 6, and ON also equals 6, so they're congruent. Okay, but then I need to find LO and MN. So LO equals, and we set up our distance formula. For L to O would be 1 minus 0 squared plus 4 minus 0 squared, or the square root of 1 squared plus 4 squared is the square root of 1 plus 16, or the square root of 17 is that length. Next, I'd find MN. And again, notice I'm labeling what it is I'm finding. MN would be 7 minus 6 squared plus 4 minus 0 squared, which is the square root of 1 squared plus 4 squared, which is the square root of 1 plus 16, or square root of 17. And again, we note that these are congruent. So I've just shown and proven to you that the opposite sides are congruent by using distance formula. I really can't in the coordinate plane prove that opposite angles are congruent unless we have just right angles, because we can't measure angles in the coordinate plane with techniques that we know at this point. That's more of a pre-calculus type topic. But we can prove opposite sides are congruent. We could show opposite sides parallel by measuring slope. Here's an interesting question. 3 vertices of W, X, Y, Z are given here. Find the coordinates of the vertex of Y. So you have W, X, and Z, but I don't know Y. I don't know why. That's kind of funny. Okay, so let's do this. And the best way to do this is with graphing, and we'll see why in just a second. Again, no pun intended there. So W is at -1, -3. So left 1, down 3, there's W. X is at -3, +2. So there's X. Y we don't know, but Z is at 4, -4. So up 4, down 4, there's Z. And Y has to be out there floating somewhere. So I draw on the sides that I know. And what do I know about parallelograms? What's special about them is that opposite sides are parallel and congruent. Y has to be somewhere. I'm not sure where, but we know that Y has to be somewhere over here in order to make that reasonable. But I'm not exactly sure where. But we can find it really simply because it has to be parallel to XW. So when I look at XW here, I notice that from W to X, I went up 1, 2, 3, 4, 5, and left 2. The slope from W to X was up 5, left 2. So guess what? I have to have the same slope from Z. Up 5. Sorry, 1, 2, 3, 4, 5, and left 2. Aha. That must be the location of Y. When I draw it in, does it look right? Sure does. And I found that the location of Y is at the coordinate 2, 1. So we've shown that very quickly. We can find a fourth point when we're doing that. And again, notice that I didn't go X, W, Z and then try to find something somewhere else. We found exactly where Y was in order. So for today, our final question is find the lengths of the sides of the quadrilateral STUV. Now, you're going to have 4 sides here you're going to have to find the lengths of. And that's what we're going to be doing for our final question today, is you're actually going to be running those calculations. I want you to find the lengths of those sides. So that's going to be our final question today in our Ed puzzle, and we'll see you in class.